Okay, now that we know a little bit about the circular motion, centripetal acceleration, and the centripetal forces, the best way to learn more is doing problems. So I picked problem number 51 from page 135, and I have taken a picture of the problem, and then I have attached to it. So now is a good time for you to pause the video and read this problem. And after that, even without restarting the video, I would like you to take a paper and mark all the forces acting on the plane. So it says the wings are tilted at an angle of 40 degrees. So here the theta angle given to us is 40, we know that. And the radius of the circle in which the plane is flying, that's what we are to find. So we just have to draw a circle, and I'm just drawing a side view of the circle. If you actually look, if you keep your eye over here, like somewhere over here, and look down, then the view would be something like this. Down here I'm drawing that. So here is the plane, and this is the center, and if you place your eye the place where I have placed it, you will see that the plane is moving in a circle. The radius is r, right? I mean, this is actually, the second one is not a very clear picture, so I'm going back to where we were, and I can actually erase this picture for now. All right, that I don't want that. And then I am going to mark all the forces acting on the plane. So let's start with the weight. The weight is directly pointed down, no matter what. Inclined plane, whatever, the weight is pointed down. And then it says there is a lifting force, aerodynamic lift, and that is perpendicular to the wing surface. So you can see that the wing surface, if I just draw this line, that is the axis of the wings, and the lift force using the same blue is perpendicular. I don't know if it is perpendicular enough, but you know, this angle is 90 degrees, that angle is 90 degrees, and I'm going to call this force aerodynamic lift, FL. So we are supposed to find the radius. Now we have two forces, and we have a circular motion, and so we are going back to the recipe given over here. I think you can, I'm going to read one by one. So first thing is, read the problem a few times, that we did, and mark the forces on the diagram. We did that. Draw a force diagram. Well, the force diagram alone would be something like this. This is the inclination of the wings. Actually, that inclination is a little bit higher than what the picture shows. That's okay. And then, as always, I like to make the object a little dot, and then here you have the weight pointed downward, and then you have the lifting force FL, and the radial direction would be like this. Actually, I don't want to draw it in that form. Let me erase that and then draw it using a dotted line, like dot 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 dot. So that is the same dot 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 over here. This is the direction of the center, and that is the radius r. Now the last step according to this is use Newton's laws. That would be sum of F equals to ma. Now we have this thing called like making these tables, and I'm going to go with those things now that we are back in problem solving. And so we have two forces, FL, and the other one is W, and so we have to take the x component of the lifting force and the x component of the Wx. So we have to find the angle. Now if you guys know that this to be a 40-degree angle, then that is going to be a 60-degree, a 50-degree angle, right? If this is a 50, then this is a 40. right? If this is a 40, then this becomes a 50 again, because this is perpendicular, that is perpendicular to the dotted line. And also if I draw this line, that also perpendicular in that form, that is also perpendicular, right? So, we have the angle. I think you can see them better now. The green square is 90 degree that FL makes with the plane, and then the red square is the 90 degree the W force makes with the positive x-axis or the radial direction. Okay, so let me get back to the tables here, and I have this blue arrow. The blue arrow points in the direction of x or toward the center. In this case, it's the same, toward the center. So I am going to take the components of FL. So you got FL cosine 50, and W here, W cosine 270. Actually, no, W cosine 90 or 270 or 90, it doesn't really matter. And then here the answer is 0, and here FL cosine 50, you can find the value of cosine 50 and plug it over here. And A sub C, that is the centripetal acceleration, we have that. We can call it V square over R, or simply AC. Okay, now I am going to the other side, to the other page. Let's do that. And here I am going to create the Y table. If you want to go back and check on the figure, you can do that, but I can't remember the angles and all. So let me put FL first, and with the Y component, W with the Y component, and A with the Y component. So FLY, that would be FL sine 50, WY, W sine 270 or 90 in this case, and AY is 0. Now you have to understand that there is no motion along the Y direction. So if I just draw that circle again, the cross-sectional view or the flattened curve, flattened circle, and here you have the plane, and the plane is going in this circular path. And clearly there is no direction along the Y direction. There's no motion along the Y direction. So you can simply say that the Y component acceleration is 0. Now we have two unknowns. One is FL, we don't know that, and the other one is the radius of the circle. So when you have two unknowns, we have to create two equations. That's not going to be a problem, because we can use Newton's second law along two different directions. So let's start with Y, because we have the Y table right next to us. And let's fill this out. We got FL sine 50 equals mass times, sorry, I got to add the weight component. Alright, and then plus W sine 270 or sine 90 in this case. You can say it's mass times acceleration. So if I just take FL to one side, you will get negative W sine 270, and that divided by sine 50. Now sine 50 I don't remember off of my head, but sine 270 I know this is a negative 1, and this negative and that negative will give you a positive value. So here you have W over sine 50. Now W is mg. Mg is sine mg divided by sine 50. So this is our equation number 1. And in order to set the second equation, we are looking at Newton's laws along the centripetal direction or the radial direction, or in this case you can call it x direction too. And that would be mass times A acceleration. And the forces along this direction, net force would be FL cosine 50. And we are getting these things from the table on the other side of the video. And then we got mass times AX V square over R. So the reason you got to understand that the reason that I replaced A by V square over R is because this AX over here, not just as AX, it is the centripetal acceleration, because this is the acceleration pointed in the direction of the center. So here I have FL equals to mass times V square cosine 50 times R down here. And this is going to be our second equation. Now you can see left hand side of these two equations you have FL and FL. So you can set equation 1 equal to equation 2. So when you are setting the equation 1 equals to equation 2, from the right hand side I am just taking only this part here, that would be mg divided by sine 50, and the other side I am taking the right hand side mv square over cosine 50 times r. Now the masses cancel out and we need to find r, and r would be v square sine 50 divided by g cosine 50. Now you know both v, not both v, just v. V is given to us as 480 kilometer per hour. 480 kilometer per hour, and you will have to convert this into meter per second and use that value. And other than that, we have sine 50, you can use the calculator, get it out, and cosine 50 same, and g you know 9.81, and v is given to us in kilometer per hour. You have to convert that into meter per second, and when you will use all those things in this equation, you will end up with the value for r in meters. So when you are doing a problem like this, well, you have to understand setting those tables, that's not new. We have done this over the last couple of weeks and even before for kinematic equations, so that is not new. And the only thing that you learn today under this section is the circular motion. And when something is moving around in a uniform circular motion, then there is a centripetal acceleration, and we can use Newton's second law in the direction of the center, where you can use the centripetal acceleration equals to v square over r. So that is the most important thing here. And you can watch this video a couple of times, and then you can set it aside and do the work all alone. And I like you to bring the work, complete the problem, bring the work to the class next time we meet. Okay, best, bye.